Studying this animal forced me to think as if it was 500 years ago, and to make an effort to think by stratification, by allegory, and through metaphor.
It's really old, much older than dinosaurs, than any reptile, so it's really a living ancestor of the first animal. So indeed, it's not like a lizard, it's a bit more clumsy. It's a wonderful animal to study, and I'm really fascinated by its locomotion.
You'd say it was a toy made of black and yellow plastic, a kind of prehistoric lizard, a little dinosaur, and in fact it's not a plastic toy, it's a real animal because it moves.
I have a lifelong obsession with fire salamanders.
Make a film. A whole film about the salamander. What a strange gamble. 52 minutes, only about a 20-centimeter long animal. Of course, this amphibian is very sympathetic with its bright colors, shining eyes, and its smile. But all the same, the life of a salamander is very, very quiet, almost boring. A slowed down rhythm, and the majority of the time under the ground, as soon as it becomes too warm or too cold or too dry. But despite everything, perhaps there is a story to tell here. 430 million years ago, fish emerged from the water, and less than 380 million years ago, our ancestors and the ancestors of the salamanders were still the same. From then on, each has made its way to become what it is now. On the one hand, a poorly adapted mammal who compensates for inferiority through technology and unusually aggressive behavior. And on the other, an amphibian which must adapt as well as it can to everything that the technology and aggression of mankind cause. Reproduction. This is what counts in the renewal of the species, and so its evolution. Males and females each transmit by chance half of their genetic heritage. The meeting of the female and male genes gives birth to new individuals who are similar but slightly different. For the salamander, this important meeting generally takes place at the start of autumn. In this season, cool temperatures and damp conditions make them come out in search of a partner. But alas, these migrations are badly disturbed by our own movements. It took 2 autumns to film this sequence. In the first year, not a single drop of rain fell between the last summer storm on the 6th of August and the first snows of winter on the 26th of November. You can talk about exceptionally dry conditions until the exceptional becomes the norm. Hard times for salamanders. At last, it is sufficiently cool and damp to allow the salamanders to come out, and if their paths don't cross ours, to be able to reproduce. They climb on each other, but there is no copulation with salamanders. Fertilization is external. The male places himself on the female and strokes her chin by moving his head from right to left. Then, deposits sperm on leaves in a small gelatinous pile that scientists have called, in their usual poetic and original way, a spermatophore. Literally, a spermatozoa door. The female inserts this gelatinous mass in her oviduct. An oviduct is an egg cavity, named with the same poetry. Fertilization, the meeting between the spermatozoa of the male and the egg of the female, will happen later, well after the partners have separated. This kind of later fertilization is an exception among the amphibians, who are more likely to do everything at once. Toads, for example, expel millions of eggs in an instant from the female, and they are immediately fertilized by the male. The salamander is a slowness expert. It places its bets on durability and quality rather than quantity. A worm nibbled from time to time, short periods of activity. The life of salamanders stretches out slowly. But they can live in this way for many decades, compared to the 5 or 6 springs of their cousins, the toads. Evolution allows adaptation, the chances of reproduction sometimes offering new abilities. The new individual is therefore better equipped to survive and thus better able to reproduce. This is the sorting of natural selection. And so, through the millennia, the salamander has acquired capacities essential to its survival. This is a cold-blooded animal which doesn't regulate its body temperature. So, to prevent frost imprisoning its body and perforating its cells during hard winters, the salamander secretes an antifreeze which allows it to stand up to temperatures as low as -10 degrees Celsius. Its skin secretes an antibiotic and antifungal mucus which protects it from external attacks. Antifreeze, antibiotic, and antifungal, so many incredible adaptations which attract the interest of researchers. So much hypothetical promise to one day help us out of the process of implacable natural selection. In the laboratories of the Lausanne Federal Polytechnic, it is in the salamander's past that an interest for mankind's future is being sought. You have to have permission to enter here, and the animals studied are special.
So in my lab, we're very much interested in animal locomotion. And for a long time, we have now studied the salamander, which is a key animal from a locomotion point of view. By modeling it, we have a bit access to our ancestor, at least the ancestor of all tetrapods, of mammals, of birds, of humans, all came somehow from a salamander-like ancestor.
We ordered also a stretchable like pyjama. So
For protection below. And
exactly, we put the pyjama first. Again, all poles here.
And did we get the suit now for swimming?
Next week.
Next week, okay, yeah. That would be cool.
Salamanders is like this big, so we took X-ray video of this animal while it was walking and swimming, and we scale up this skeleton, and then we create this robot. So basically, it's a real replica of the real animal, and we make it walk at the correct speed, and also swim in order to validate this methodology we use in order to design robots out of animals. Our scientific interest is basically to use biology to build better robots, to then use the robots to then study biology.
So the main purpose of what we do is really scientific knowledge. And this is very important from also medicine point of view. Understanding the spinal cord circuits in animals, including in humans, is very important because in the future it can help to, for instance, restore locomotion paraplegic patient. If we understand how the spinal cord works, we can maybe stimulate electrically or help a paraplegic person to walk again. And now, indeed, when you take inspiration from biology to apply it to robotics, you can also go beyond biology and do things that animals cannot yet do or are not doing.
Allowing paralysed people to walk again, to go beyond the capacities of living. An astonishing promise hidden in the approach of the salamander. A human being with imagination sees a number of promises in this little black and yellow amphibian, and this has been happening for a very long time. In antiquity, the salamander symbolized the element of fire. For alchemists, it was the living incarnation of sulfur, the final step of mercury heated for years before it transformed into the philosopher's stone. In the Middle Ages, it was thought that the salamander could resist fire, that it could poison spring water, and even that it was immortal. By closely observing the fire salamander, explanations for the ancient beliefs can be found. The salamander is covered in yellow marks which evoke flames. In case of danger, it secretes a toxic liquid that burns anything that tries to devour it. Also, since it hibernates in logs, it's easy to imagine it coming out of a burning log before the wonder-struck eyes of people in the Middle Ages. Most of all, it has this unbelievable ability to regrow severed limbs. But there, where we, modern people, look for rational explanations, in the past, people saw in all these clues an expression of the true nature of this animal, which was hidden beyond the visible. If you wish to see this true nature of salamanders, the most certain way is without any doubt to go to Chambord. In his castle, Francois I had its emblem sculpted everywhere, even though at first sight these water-spouting dragons only resemble salamanders vaguely.
At the beginning, when I widened my knowledge of this animal, I really had a 2019 mind. That's to say, I was looking for a single meaning. And since, progressively, studying this animal forced me to think as if it was 500 years ago, and to make an effort to think by stratification, by allegory, and through metaphor. So I'm deeply indebted to this animal, a real light and illumination in the sense of intelligence. There's a lot of intelligence in these emblems.
In the Middle Ages, it was believed that living creatures were created by God, who gifted them with characteristics hidden behind their appearance. Observations by sages could only confirm these divine characteristics, which are found symbolized in each of the 837 salamanders sculpted at Chambord.
Here there are 200 sculptures of salamanders, and not one is the same. So this is a masterwork. It was the best workers in the kingdom that sculpted this. There are 2 sites like this in Europe, Chambord and St. Peter's in Rome.
By decrypting each of these sculptures, François Parot has retraced the road to understand what people in the Middle Ages saw behind the salamander.
So the salamander, what was known about it in the Middle Ages and the Renaissance, at the start of the Renaissance? Little. It was supposed that it had a quite exceptional power to regenerate. I think this was observed in nature, that this animal could have 6 fingers and maybe that parts of severed fingers regrew. It was supposed to have a special kind of sexuality, that it was quite simply asexual and that it could be born simply from the soil, from silt. It's not difficult then to associate the salamander to the Immaculate Conception of the Virgin Mary. So we can see the counterpart here. In the same way that it could regenerate its body in a spectacular fashion. So immortality isn't far off. Hence the symbol of Christ. So, there's another. There are 2 others, and this one on the guardrail is truly exceptional as well. And then the ultimate there. It's more exceptional up there on the arch of the staircase, surrounded by flames as well, spitting water. That can be clearly seen. But you can see other things there, in particular by playing off the 2 salamanders, in particular the highest one up there, which is even more in the form of an S. And that S, that letter, because it looks like the letter S, is a very important emblematic letter in the Middle Ages, which is the first letter of the Latin word spe, which means hope.
François I never lived in the castle of Chambord. He just stayed there for a few nights. These 440 rooms, 282 chimneys, 32 kilometers of walls, and 837 salamanders aren't the attributes of an oversized residence. They're messages, promises, prayers to the people, to rivals, or to God. A salamander 2 meters in length, sculpted at a height of 56 meters, is a warning. It spits water capable of extinguishing the flames of the English dragon. A baby salamander hidden between the paws of an adult in the private chapel of the king. This is a prayer to God to have heirs. And everywhere is the S of hope. That gifted with all the capabilities of the salamander, and especially immortality. In a certain fashion, François I acquired that immortality, perhaps thanks to the salamander. "500 years later, this quest for immortality continues. But globalization leads to these promises of infinite life being Mexican. The axolotl, a salamander that can keep its childhood characteristics all its life, like external gills. In the wild, it is threatened. However, it is among the top 10 of animals the most studied in the world. Thanks to, or because, according to whether you're a researcher or a guinea pig, its incredible capacity to regenerate. When a researcher has the funny idea of cutting off a paw from an axolotl, it takes just 1 month to grow a new one, and this as many times as the researcher wants.
So the axolotl is known for its fantastic level of regeneration. From the moment that its survival isn't in question, it will regenerate in a perfect fashion the organ that has been lost. Its tail can regenerate, but also its eyes or part of its brain. If it loses a paw, that paw will regrow completely, remake bone, regrow muscle, repair skin, remake the nervous system, and be as completely functional as if the paw had never been amputated.
In his laboratory, Laurent Cohen studies more in particular cardiac regeneration. To understand this phenomenon, he compares different animals capable of regenerating after an operation causing similar effects to a heart attack. The lucky candidates for this great scientific adventure are the zebrafish, the clawed frog, and the axolotl.
Following a heart attack or a wound to the heart can regenerate in some species, like amphibians and fish. However, in other species like man or other mammals, this capacity doesn't exist. And so, the objectives are to know why some species have this capacity to regenerate and others don't. And in the same species, how is it that this capacity is transitory? And what are the mechanisms that lead to a loss of that capacity to regenerate?
In terms of regeneration, the young are often more efficient than adults. For the clawed frog, for example, tadpoles can regenerate their hearts perfectly, while the adult is incapable of this. The axolotl, which is happy to remain a child all its life, always keeps its ability to regenerate.
We use what is called an immunological reaction. So here we can color muscular tissue, specifically in red and in green, specifically fibrous tissue. That's equivalent to scar tissue. So here we have the heart of a tadpole before the wound. After the wound, we see the appearance of fibrous tissue, of a temporary scar, then over time we see it is progressively eliminated to arrive at a heart which presents a structure that is completely correct and no different to the original heart. So there's been complete regeneration of the heart with progressive elimination of fibrous tissue. In an adult, when we do that, this scar appears. But if you look at it after a time, this scar here on the adult's heart doesn't go away, and that scar will disturb correct heart function throughout the adult animal's life.
The tadpole regenerates, the adult doesn't. Between the two, there is a metamorphosis induced by thyroid hormones. If the zebrafish is given the same hormones, it will lose its capacity of regeneration. It's the same for the axolotl. Plunged in a bath of hormones, it undergoes artificial metamorphosis, which take from it at once its external gills and its extraordinary capacity to regenerate. As for man, it has been seen in the few children that suffer a heart attack that they have no trace of the accident if it takes place before the great hormonal upheaval of puberty. The moral is, keep your heart of a child. The burden of hope carried by the salamander is great. a spinal cord capable of allowing the paralyzed to walk again, a heart which can save us from the faults of our way of life. Because cardiovascular diseases are the main cause of mortality in the world, and they are intimately linked to our modern way of life. Sedentary behavior, overconsumption, poor diet, so many reasons to have a heavy heart. If we add to this a good dose of endocrine disruptors found everywhere in our daily life, in water, food, shampoo, makeup, clothes, food packaging, carpets, cars, and the air. Thus, we have our puberty on average 5 years earlier than last century. Sick hearts and less time to regenerate them. With that, it's difficult to be light-hearted. This winter, it has snowed. The return of fine weather has melted the stock of water which has swollen the temporary streams. This spring, female salamanders have left hibernation to go to the streams. Science says, always in a poetic way, that the fire salamander is an ovovivipary animal. It lays eggs which hatch when they are released. Throughout the winter, the female keeps the fertilized eggs in her warm stomach. They have slightly developed there. The snow has melted, the streams are full, everything is ready. To stop predators eating the vast majority of the eggs each spring, the salamander keeps them inside until they hatch. Once again favoring quality over quantity, the salamander gives birth to less than 20 larvae before returning to their underground shelter. They're called larvae because even if they have hatched, a real metamorphosis awaits the young salamander. This deep change takes it from aquatic to terrestrial life. For the moment, they are nothing like a miniature adult. With its feather-like external gills and long dorsal fin, it's totally adapted to life underwater. To protect itself from predators, it can only count on its discretion, as it doesn't yet secrete the toxic substances which make adult salamanders inedible. But as it's capable of changing its skin color, To imitate the bottom of the streams, its camouflage is quite effective. This is also an advantage for hunting copepods, the tiny crustaceans on which it feeds. Progressively, it colors itself in black and yellow to show that it has become toxic. This warning is very useful for the whole species. If a predator tastes one, it will remember it all through life, associating these marks to an unpleasant memory. The tail becomes cylindrical, the external gills are reabsorbed, and lungs develop. The young salamander spends more and more of its life at the air-water limit. Then one fine day it becomes terrestrial. It will only return to the water to lay eggs. The fire salamander spends most of its existence hidden in the deep topsoil, often in the galleries of voles. But it's an amphibian, leading 2 successive lives in 2 different environments. An aquatic life, a terrestrial life. It seeks out tiny pools or temporary streams to lay its eggs, because it needs the least number of predators to have a chance to become adult. Alas, these pools are more and more rare, often polluted, concreted over, or too quickly emptied because exceptionally dry conditions have become the norm. During the scouting of sites for this film, among the favorable sites which were chosen, 1 out of 2 no longer had salamander larvae. In the Swiss Prealps, at least there's no lack of water. But because of the altitude, the streams are too cold. Impossible for salamander larvae to grow up. However, if you walk here under a cool summer shower, you may have the chance to meet a salamander adapted to the extreme conditions of the high mountains. Even if it's toxic, it has abandoned the yellow marks. The most important thing for it is not to escape the rare predators, but to capture a maximum of warmth. And to resolve the problem of water temperature, it has developed an incredible strategy.
The black salamander is an animal which lives in a small area of the Alps, in the ranges truly at the fringe of the alpine chain, which are very humid, which have a lot of mists, lots of fogs, a lot of damp. And this salamander has a particularity which is almost unique among European amphibians, which is that it doesn't lay eggs or larvae, which have to develop underwater, but really two babies which are truly replicas of adults. So these salamanders have no more need of water to reproduce. A pretty caterpillar, no? That's nuts, because I've walked down this little valley here, and in 20 meters I've seen 5, 10, 15 on the track. They're here, but they're hiding. It's the right place, but the wrong day. In fact, the female black salamander has a lot of eggs in her belly, but only 2 will be fertilized, and that will give 2 larvae, which develop completely inside her during 2, 3, 4, even 5 years. These larvae grow little by little. At first, in the first year, they devour the unfertilized eggs, and they breathe with 2 long gills, which grow like that on the 2 sides of their heads, which are pink and allow them to absorb oxygen, which is in the liquid that is inside the body of their mother. Finally, it's a pretty crazy story. Then their mother secretes these kinds of small masses, little lumps, protuberances on the surface of the cavity, and these 2 salamander larvae have little teeth, and they literally graze on this tissue secreted by the mother to grow and grow and grow until they are big enough and until they have transformed into terrestrial amphibians. And when they finally come out of their mother's stomach, they are little black salamanders, perfect replicas of their mother. So in fact, with amphibians, there are classic cases. Frogs, toads, which lay thousands of eggs every spring, and with a lot of luck, maybe a tadpole will become an adult. Salamanders are really another extreme. Already for the fire salamander, it's a few dozen larvae a year for each female. It's very, very little. And then the black salamander, which is really the extreme case. It only has 2 young every 3, 4 or 5 years. So that takes a very long time because it is cold, because salamanders are slow creatures with a metabolism that is a lot less rapid than that of a mammal or a bird. So I think that it takes them really several years to accumulate enough energy and to feed their young enough to reach a sufficient size. So it's really very, very long.
Black salamanders have taken millions of years to adapt to the extreme mountain conditions and to free themselves from water. A comparable phenomenon can be seen in the north of Spain. The town of Oviedo has developed an isolated population of salamanders. Separated from the rest of the world by walls and roads, this population survives in fragments in micro-sanctuaries like the San Salvador Cathedral Cemetery. Like their alpine cousins, these fire salamanders have freed themselves from water to adapt to heat and drought. This strategy has allowed them to survive while urbanization makes water less and less accessible. As the temperature of Oviedo is clearly more clement than the Swiss mountains, salamanders don't carry their larvae for several years. It takes just 3 months to see up to 15 young individuals identical to the mother. It's fascinating to observe this capacity of adaptation to life acquired thanks to reproduction. this fashion of avoiding the obstacles to survival. It's even comforting to see that, despite human aggression, life continues to make its way. But the obstacles are greater and greater and getting closer. The race to adapt is looking like a cross between a hurdles race and a long jump. Forests are transformed into fields of trees. The fields are turned into toxic deserts. It's not just water that is missing, but food, reproductive partners, and habitats. Added to all that, our incessant need to consume things made on the other side of the world implies disastrous consequences.
So what we have here is a fire salamander from a private breeder. And this animal shows the typical lesions that can be associated with a B-cell infection. You see the typical yellow and black of a fire salamander, which is completely normal. But if you look closer, then you see these small black spots in the yellow of the animal. And that is not normal. So these are the skin lesions caused by the fungus in the animal.
In 2008, Dutch naturalists made a terrible discovery. Entire populations were vanishing in very little time. The guilty party? A fungus which is called Batrachocytrium's salamandrivorans, the salamander eater, otherwise known as Bzal. Research began dissecting, sequencing, analysing, and taking samples to understand this new menace. The fungus came from Asia. European salamanders felt the full impact of a pathogen they didn't know. During this time, the disease spread through Holland, Belgium, Spain, and Germany, each time just as virulent. An entire population of a site contaminated in a few months with 99% mortality.
So it is a big threat, and it can be put at the same level as, for example, all the habitat alteration and loss combined. So what you see here is a histopathological image of the skins of the fire salamander that was suspected to be infected by B-cell. I will show you. Then you see basically that the skin is completely gone. And here we had this normal skin, but here you see that the skin is actually completely destroyed. And all these dots you see here, these are the fungi. And the fungi have literally eaten away the skin. Most likely, they hitchhiked with live amphibians across the world. One way is the pet trade. So a lot of amphibians were imported into Europe for the pet trade, so to be kept by private keepers. So that's one way how these fungi could have entered Europe. But there are several other ways as well. For example, xenopus have been moved all around the world because they were used a lot in lab experiments. And then a third way how it could have spread through live amphibians is for food consumption. Think of frog legs.
Most of the frogs that end up in our plates come from Asia. An Asian disease which is caused by our taste for wild species and which, through globalization, crosses frontiers to spread around the world. The history of man sometimes is like that of salamanders.
If we detect the B-cell in a new site, for example, we propose to catch all animals, to disinfect the whole place and to fence it so that no people can enter, so to limit the dispersal, the further spread of the fungus.
There is no possible remedy in nature, no effective confinement to flatten the curve. The fungus arrives, the salamander disappears. There's probably no possibility of reintroduction either, because the spores of Basal still exist on sites where it appeared several years ago. Salamanders can only count on their capacity of adaptation to counter this new menace. Fortunately, the fragmentation of habitats which isolate one population from another slows down the spread of this salamander-eating fungus. Fortunately, it's difficult to use that word because the isolation of salamander populations is a big menace for the survival of these animals. And it's unfortunate to say that it's probably the only thing which will limit the damage caused by Basal. Fire salamanders are still widely found in Europe, so it's unlikely that Basal will drive them to extinction. It's just another menace for our amphibian. But if by mischance one single fungus spore reaches one of the endemic populations of salamanders, like the black salamander of Switzerland, or the Oviedo salamander, or even the Mexican axolotl, then that species will disappear forever, taking with it all our hopes. It is possible to take comfort from the certitude that despite all we have inflicted upon it, life always still finds a way to adapt. But it's not certain that with all our science and technology, we can manage to do the same. To make a film, a whole film about salamanders, what a strange gamble. But after this story, if some people find themselves fascinated by this little amphibian, if some people find themselves wanting to do some small things for them, then this gamble will be won. The salamander's gamble.